Hi, Roselle. I am about ready to admit defeat on this one, unfortunately. I'll explain to you what I've got so far, what I've worked out so far on this. If we start with a regular set of axes and we start with the drone at -1 because he said that he wants you to have the intersection at the origin at 0, 0. Then it would be like 1 kilometer below the intersection or south of the intersection. So we know that the train's moving in this direction, and we know that the drone's starting here at the -1, and it's going to be following the pursuit curve shape like that as it tries to catch up with this guy, okay? So the part that where he said to you that he wants you to start with the derivative first, or with dy dx first, the first derivative first, that's what he said. What you're going to do for that is you're going to try to find a tangent to this curve at any point along the curve, and you can use any point here on the axis to create that tangent, because all of the points for the train are going to be along the x-axis. We know that, right? So what we can, that does, I'm just looking at that diagram and going, that doesn't look like a tangent line. So it should be like this, and then there's a point, and then it's going to be tangent to the curve like that. Sorry, my diagram was not very good. So what we're going to do is we're going to name the point on the x-axis. It's going to be over A, sorry, it's going to be over it's going to be over A. I was right in the first place. Start again. It's going to be over A on the x-axis and up 0 on the y-axis. And then down here, we're going to have a point, and it's going to be a point that is over B on the y-axis, or on the x-axis, and up. We can call that negative y because we only have one y value, because the other one is a 0. So we'll call that negative y, because that's the position. Like if we wanted to get to that point, we would go over on the x-axis and then down to that point, so it would be negative in the negative y direction. Now, dy dx is just the slope of that tangent line, which is, basically just m. So we're going to do y2 minus y1 over x2 minus x1. And so for our points then, we would have, let's assume that this point is ahead of the other point, we would have y2 minus y1 over x2 minus x1, and that would give us 0 plus y over a minus b, or just y over a minus b. And so dy dx could be defined like that. And when it comes to finding a, we could even do another substitution. Let me just do a little margin thingy over here, because a is going to be a function of the speed of the train, which is 100 kilometers an hour, right? So a is just 100 times t, when t's in hours. So that would be like a kilometer per hour sort of rate. So whatever distance a is, it would be how much time has passed times the 100 kilometer an hour rate that it's going. So if you wanted to, you could go back down to this equation here, and you could recreate dy dx and write it as y over 100t minus b. Now we can't do that for b because b is an x value on the arc length curve. It's on the curve, and we don't have an equation for the curve, and so we can't use that 200 kilometers an hour. That's going to come in later because if we now, like, I know he said it was distantly related to the arc length. I'm just looking back at your email for a minute, and it says that the problem is distantly related to arc length. The reason he's saying it's distantly related to arc length is that the arc length formula is this. Oh, sorry, dy dx squared dx. Okay. That's the arc length formula, and if you look at that, you can see that it's really similar to the formula that he gave you for what he wants it to look like at the end. You know, the one he's saying that he wants you to prove that it comes out to that. You've got the bracket, the 1 plus dy dx squared, and on the other side you have 2x d squared y dx squared. So let me just show you what's going to happen here. Okay. So what he was saying he wants you to prove is that the differential equation representing the path of the drone is this. And so he gave it to you, and he's saying that that occurs when that dx dy equals 1 at y equals 0 or x equals 0. I can't remember what he said about that. So this formula, the arc length is here, right? And so that looks exactly like that. That's where that part of it is coming from. This 2 comes from the fact that the speed of the drone is 200 kilometers an hour. And the speed of the train is 100 kilometers an hour. And so this is actually a K. It's a ratio of the speeds of the two things. And so this is one of the few times that the sort of two objects will meet. If they were traveling the same speed, they would never meet. But in this case, because the ratio of their speeds is 200 to 100 or 2 to 1 or just 2, then they actually will meet because the drone's traveling faster than the train. So that's where the 2 comes from. And the rest of it is from some really complicated differential equations with arctans and all sorts of weird things in there. And I don't think that you guys are responsible for being able to do derivatives and integrals with arctans and things like that. Now maybe I'm wrong, but I don't think that you've done all that yet. And that's where I'm running into trouble. If you look at the video that I sent you in this email, it uses the arctan idea, and that's sort of the simplest example I've been able to find of how to deal with this once you get to that point. After that, it just gets too hard for you to take the derivative and the second derivative and so on to get back to what you want to get back to. The other part that makes it really confusing is that the video I sent you, it's got the axes reversed because the pursuer is leaving from the x-axis and the pursued train is traveling on the y-axis, and so it's backwards from what we're trying to do here. So all those slopes are upside down, so that makes it a little bit more difficult as well. So anyway, have a look at that, and unfortunately that's all I really have for you. I don't know if you want to sort of delve into that and spend any more time on this one, or if, as you say, you can just kind of take that as your lowest one and drop it. But I've put in quite a bit of time on this one, trying to figure out a way to make this more simple and more sort of in tune with first year calculus, and I just can't do it, and I'm really sorry.